Okay, now we will explain the next method. If you have if you have three or more I'm sorry, not metrics. If you have three or more equation, suppose I have 3, then we can use this determinant and Cramer's rule. Suppose I have 3 equation, okay, suppose I have 3 equation and I can write this into metric. So this in the metric form I will have A, this is the matrix A, and then the determinant of matrix A or we call it as D metric, or not metric, this is the determinant. It's scalar, it's just not matrix, and also it's not vector, but it's only scalar. So this is the determinant of A is like this. The notation is like this. So you have to differentiate between the notation of matrix and its bracket, and this determinant bracket is different. Okay, and how to find determinant? Do you still remember how to find determinant? I hope you still remember, because in first semester you have linear algebra. and of course you learn how to find determinant there. Minus A12. So this is how to calculate the determinant, and how to solve this. I will just give you one example. So this A22 will be multiplied by A33, then subtract by this, multiple by this, okay, and be careful that we have to multiply with A11, all of them, and the other term is just the same calculation as here. And then how to find the solution, we can use Cramer's rule. Cramer's rule says that x1 is the determinant of C1, A12, A13, divided by the determinant. So you can find x1 by using this formula, and as you can see that the coefficient of x1 we replace with the constanta, the c. And then if you want to find x2, you replace the coefficient of x2 with c1, c2 and c3. So you will have this is A11, A21, A31, and this is c1, c2, c3. Divided by determinant. And if you want to find the x3, it's just the same calculation as x1 and x2. You can do by yourself for finding x3. Okay, this is Cramer's rule. You can directly find x1, x2 and so on by using this formula. Of course, you have to find the determinant first. Okay, now we will see an example. Let's see an example. Suppose I have 0,3 x1 0,52 of x2 then the second equation is this. Okay, these are my equation. And then how to find the solution of this equation? It means that I have to find x1, x2 and x3 which correct in all equation by using Cramer's rule. So first we have to find the determinant. Well, actually I like to use this point to present the decimal value rather than comma. So if you confuse with my notation, well, I will not use any thousand separation. So if I use dot, it means that it's decimal. If I use comma, it's also decimal. This is 0.5, 1, 1.9, 0.1, this is 0.3 and 0.5. You can use the formula of determinant. You can calculate by yourself and you will find this value as the answer or as the determinant of this matrix. So after having the determinant, I can find x1. What is x1? x1 is the determinant of the first constant, or c1, the second constant, or c2, and this is c3, and this is a12, a22, a32, and then this one is 1, 1.9 and 0.5. Divide by the determinant minus 0.0022. If you calculate this determinant, then you will and divide by this value, and you will have this result. Okay, so this is the x1, the solution of x1, and you can do the same thing as I already explained in Cramer's rule. You can find x2 also, should be minus 29.5, and you can try to find your x3 by yourself. Okay, this is Cramer's rule. I hope you can try this calculation. At least you can try how to use Cramer's rule. We will continue to the next method.